All right, we're now in chapter 3, which deals with electromagnetic spectrum. As you can see on the screen, how it is displayed. It can also be displayed in another form. For example, what we have in our textbook, figure 3.1. Now, going back to the diagram before us, which is electromagnetic spectrum. The top horizontal line represents the wavelength, which is measured in meters. Right at the most bottom horizontal is the energy of electron, energy of a photon measured in electron volts. On top of that is frequency, which is the wavelength per second. In SI unit, it is in hertz, which is the most recent and agreed upon by the international standard. Now, we see here that the frequency, as the frequency increases, if you look at it, so also is the energy increases, which means that frequency is directly proportional to the energy. The higher the frequency, the more the energy. On the other hand, the wavelength, as the wavelength increases, the frequency decreases. In other words, we can say that the frequency is indirectly proportional to the wavelength. Now, the sketches in between, say for example, we have the soccer field, the house, baseball. It gives us an idea of measurement, how big wavelength is, such as a football field might be 100 meters, that of a house being less than that, and then the baseball is also smaller than that of the size of a house. Now, still on that, if you look at our textbook, you have the wavelengths specified or broken down in radio waves, infrared, ultraviolet, hard X-ray. As I said, the X-ray frequency, if you push now, is higher than the wavelength of a radio wave, which means the higher the energy, as I said before, the higher the frequency, the higher the energy, and that's why in X-ray measurements, it takes more energy, it has more energy, and that's why when you look at an X-ray, you'll be able to see the picture clearer, indicating that the energy level there is much, much higher than at radio wave. Now, if we go further, taking the sketch in our textbook, we have the, the visible light, which is what we use most of the time. Now, the visible light, at the lower end of it, you have the infrared, followed by red color, orange color, yellow color, green color, blue color, violet color, and ultraviolet. The easiest way you can remember that, we say Roy G. Beef. You have the red, orange, yellow, green, blue, violet, indigo. For now, That's much we can talk about electromagnetic waves. However, if you have questions, kindly direct it to me by email or you can call me over the phone. Thank you.